7.25. Two disks of moments of inertia I1 and I2 about their respective axes normal to the disk and passing through the center and rotating with angular speeds omega 1 and omega 2 are brought in contact face to face with their axis of rotation coincident. A. What is the angular speed of the two disk system? B. So that the kinetic energy of the combined system is less than the sum of initial kinetic energies of the two disks. How do you account for this loss in energy? Take omega 1 is not equal to omega 2. Means one disk is suppose here, another one is here. Both are rotating with respect to the rotational axis. One is rotating with angular speed omega 1, another one is rotating with angular speed omega 2. And their moment of inertias are I1, I2 given to you. Now during the motion, these two combines like this. And then jointly it rotates. Now here external torque is not acting. So angular momentum will be conserved. So initial total angular momentum, that is I1 omega 1 of the first disk plus I2 omega 2 of second disk, that is equal to the final angular momentum. So both the disk combines. So total moment of inertia, that is I1 plus I2. And suppose this combined system rotate with angular speed omega, then I1 plus I2 into omega. So omega, that is I1 omega 1 plus I2 omega 2 upon I1 plus I2. So question A is solved, angular speed of the two disk system. Now kinetic energy. So initial kinetic energy of the system, that is kinetic energy of a first disk half I1 omega 1 square plus kinetic energy of a second disk half I2 omega 2 square. Then when this two disk combines, final kinetic energy of the system K final, that is equal to half resultant moment of inertia I1 plus I2, and system is rotating with angular speed omega, so into omega square. But now here substitute the value of omega. આ equation જે derive કર્યું એ અહીંયા omega ની જગ્યાએ મૂકી દો. So I1 omega 1 plus I2 omega 2 whole square upon I1 plus I2 whole square. So 1 I1 plus I2 cancelled. So K final, that is equal to half into I1 omega 1 plus I2 omega 2 whole square upon I1 plus I2. Now change in kinetic energy, that is final kinetic energy minus initial. So final, that is this one, half into I1 omega 1 plus I2 omega 2 whole square upon I1 plus I2 minus K initial. So initial, that is half into I1 omega 1 square plus I2 omega 2 square. Take half common. Then simplify this one. So I1 omega 1 square plus 2 I1 I2 omega 1 omega 2 plus I2 square omega 2 square upon I1 plus I2 minus this one, I1 omega 1 square plus I2 omega 2 square. Now take I1 plus I2 LCM. This term as it is, I1 square omega 1 square plus 2 I1 I2 omega 1 omega 2 plus I2 square omega 2 square. Now multiply I1 with these two. So first term minus I1 square omega 1 square. Second term minus I1 I2 omega 2 square. Then multiply I2 with these two. So minus I1 I2 omega 1 square minus I2 square omega 2 square. So I1 square omega 1 square and I2 square omega 2 square. Both will be cancelled. Now from these remaining terms, we can take I1, I2 common. So I1 I2 upon 2 into this I1 plus I2. So into bracket we will have minus omega 1 square, this one, plus 2 omega 1 omega 2, then minus omega 2 square. Now here take negative sign common. Then you can write I1 I2. If you take negative sign common from this one, then this bracketed term will be omega 1 minus omega 2 whole square upon 2 I1 plus I2. હવે જુઓ અહીંયા omega 1 minus omega 2 whole square is appearing. એટલે આ ટર્મમાં omega 1 is greater than omega 2 or omega 2 is greater than omega 1. કોઈ ફરક પડશે નહીં. આન્સર પોઝિટિવ જ આવશે. I1 I2 always positive હોય, મતલબ કે resultant answer that is negative. So when you take kf minus ki that is less than 0, it implies that final kinetic energy is less than initial one. Clear? So loss of energy, that is due to work done by the system. Clear to all of you?
Yes,